Okay. Can you see my R screen, R Studio screen, everyone? Is it visible
Yes,
to you
ma'am.
all?
Yes, ma'am. It's
Okay.
visible to everyone.
So I'll first start with a data frame. I think in the first class you have known how to set directory, how to set your working directory from file also you can do, or from set WD, wherever you have kept the file, you can just open it. So because I have shown how to do the data entry, so I'll just show. So you can run directly from the R, or you can use Control Enter to run. So whichever you want to first type, and if you want to run, press Control and run, or either just can press Control Enter to run the same thing. So there are two ways of running in R. So if I am writing or I'm giving the input as 1:20, then what it does, it from 1 to 20, it prints out. So this is just how to input in R. It may be a revision of the classes which you have done, just to show the input entries here. I'm showing that. Data frame. Now, basically, I want to ask, are you doing it along with me or are you listening to it? I mean, now you can do it along with me because listening to you cannot be much productive. So are you doing it along with me, or I want to ask two participants, or are you just seeing the demonstration?
Few of them are using laptop, ma'am. Rest of them are using mobile itself. They have joined
Okay.
using smartphones. Maybe those who are using laptops, they may be doing hands-on. We have
Okay.
recommended them to use the laptop.
Okay. Better to do hands-on along with me, and you can use laptop also along. You can listen to it in the phone, and you can use your laptop to do some data entry and do your data analysis. So data frame we can create also. Like we are assigning a value x to the data frame, and we are from 1 to 4 we are giving the number, and again we are creating another column, true, false, false. I'll just run, and then this is how we create a data frame in R. We are also creating a data frame by importing a CSV file or notepad file, but this is what how we get through data entry directly from R. So here what I want to say, this is a read.csv, hard.csv file which I have taken. This you can get, this hard.csv file you can get in Google if you just type hard data set. For 1 minute, I'll stop sharing and I'll show you in my slide where to go. If you're doing it along with me, then what you can do is you can go to the, I think this is visible now. This is visible. Uh,
Yes, madam.
so if you type hard data set in Google, then what you'll get hard failure prediction or heart disease data set in Kaggle. So those who are doing it along with me, this hard data set, I'm also showing you how to get the data set. There are many data set repository where you can get that data set. Like in Kaggle, type the data set name and you can get it. Like when you get the heart disease data set in Kaggle, what you do, just open it. If it wants you to register, just register it. Just you have to enter through your Google account or any other account, Gmail account or something else, and then it will give you access to the data set. Then directly you can download the data set, as I have done yesterday. What I was checking the data sets, and this data set easily I can enter into Kaggle, and I can download the data set. It's a 9 KB data set, and when you download, you will get directly the CSV file here of the hard data set. For those who are doing it along with me, uh, I'll give you some time. Just you Google hard data set, you come to the second option or third option anywhere you get, and just register through your Google or Gmail ID, wherever you can take the enter, and it will allow you to download the data set. When you download the data set, put in the same directory, working directory, or wherever you are working, and then you start working with the data set along with me. So just let me know. I think there should be no problem. It is easily accessible, this hard data set or any other CSV file which you have. I think you have some files. Hard data set I'm taking because it has some categorical data, some other data sets. If your data set doesn't have any categorical data, you can just take this hard data set or any other data set. If you have data set having categorical, you can um, just skip this part. Otherwise, to do it along with me, you can download this data set, hard data set from Kaggle. Just Google it out and then uh, download the data set. I think this is clear how to get the data set from Kaggle, which I'm using. Or if you have any other data set with the categorical values or any other values, you can take it. So I hope you've got from where to get the hard data set. I'll stop sharing this PPT and I'll go to the R console. This R console is visible.
Yes, madam.
Can I get? Okay. I'm waiting for 2 minutes so that people can get the hard data set. Those who want to work with the hard data set in Kaggle, or you can take any other data set which you want, and better do it along with me, and then you can practice it together. So this is the hard data set. When you download, you'll get it in CSV only, comma separated format, and this is the data set. I'll just run the data set and show you the data set here. The data set, this is view. View the data set. So this is the data set, okay, here. So here, what I was telling was categorical data. In gender, this is 1 and 0. Then one can be male and 0 can be female here. Or in categorical data set, chest pain is there. Typical, asymptotic, then non-typical. These are various categorical data which are present in the data set. So in order to work with categorical data, you take some similar data set which has such values like here ADH, yes or no, or categorical. You can always classify it 0 and 1, which are binary. These are all categorical data sets. So this data set has these columns. So we'll try to take the data set to do some categorical data analysis just to see what kind of data can be present and how to work with these data sets. So this is the data which we are opening, and this is the data you'll get while opening the CSV file. And this is the data set. So we have seen the data. What are the categories present? Okay, I'll just tell you the categories: age, then sex, then chest pain, rest PP, cholesterol, FPS, then maximum heart rate, and so many. I think 14 or 15 such categories are present. You have that data set. Okay. So can I get some responses if you people are facing any problem getting the data set, or any other data set you have got which has categorical you are working? So may I get some responses from you?
Request attendees to respond to madam's questions and
You can type it out also. I think typing it out also. Or anyone can also speak. Like, if you've got the data set, if there is any other problem in getting the data set, then take another data set which has any other categorical value, because I'll be doing some of the analysis taking categorical data set. In case it is not there, then take any data set and because in this section, what we'll do, we'll subset it, subset one column, then we'll subset three columns, or we'll check how can we subset the data set. If we want to take only one category and work with it, how to do that. If we want only three, we don't want so many categories as in the data set. There are so many categories present here. We don't want to work with so many categories. We can just subset into three or two or one column here. So
Did everyone get the data?
okay. I think I read one that said that got the data. From one, I got a response.
I request all panelists to please confirm whether you have the data, or else you will not be able to follow, because today we are using this data for all the experiments. Request all panelists to type yes if you have got the data. If not, please print it out here so that we can make some arrangements to send you the data.
You can share it to our mail ID so that I can forward it to all the participants.
Anandita, please share it on the email ID STA, that he will forward it to all the participants immediately.
Actually, it is present in Kaggle. I can give the link, but the thing is, you have to register to get enter, and you can register through Google. Just sign in Google, and they can register.
No,
Okay, I'll again show.
I think you can download it in your laptop, and
it is downloaded already there. Should I share it
share
through
the
mail?
share the URL, ma'am. That will be helpful.
Also send a copy to STA email ID.
Okay.
We will quickly distribute it.
Okay, fine.
All of you, please hold on. Anandita is sending the data to STA, and then they will further send it to every one of you. If you can download it in through Kaggle, also is fine. Or alternately, she is sending you through email. Anita, please also write the link from where they can download in case they want. Both, please provide both the alternatives. Mark a copy to me also in the email.
I've sent the data set through mail. I'll give the link.
Is it the data received at KSTA email?
I had the mail
Not
ID.
yet, sir. I am checking.
Yeah, please check. Please check.
In chat, I'll give the URL so that everyone can get. So in chat, you people can get the link to the data and just enter through Google and get the data set. I have mailed the data set also.
Please forward it to all the participants in case they are finding it difficult to download from Google. So if you go to the Kaggle website, I think the data is very small, 35.92 KB, 36 KB. So you can very easily download, or else you can use the already downloaded data, and it will be forwarded to KSTA email. You have already received, please click yes, so that we can count and come to know approximately how many of you were able to successfully get the data set. Just type in the chat box. I request KSTA to please share the data through email, all the panelists.
Yes, sir.
Okay.
Okay, I'll continue when you will get the data set.
Just hold on.
Yeah.
Just ensure that everyone has the data before we proceed, or else they will not be able to follow.
Sir, the mail not yet received, sir. So please,
Yeah.
please.
The email ID is KSTA dot.
Yeah, I have messaged it.
Okay. I'm going to forward it once more. Just hold.
Okay.
KSTA.gok@gmail.com, right?
Yes, sir. Yes, sir.
Okay. There is one more. Yeah. Okay. I'm forwarding it once more.
Okay, Tundra.
Okay, the same email ID I have forward already attached.
Now we have received, sir.
Okay. Thank
I
you.
will forward it to all.
Yes.
Thank you, sir. Attendees to share their mail IDs. I am forwarding you right away. Request everyone to check their inbox. I have forwarded the data set so that you can work out with them. I have forwarded those who have sent email IDs in the chat box. Please check your inbox.
Shall we proceed? Everyone has the data.
Yeah. And also the link is there. Those want, you can just directly go to the link and get the data.
please type in the chat box whether you are ready with the data so that we can proceed. Okay, Anju Srinivas says, yes, received the data. Anyone else facing a problem?
If any of you facing any problem, please let me know.
Bean says, didn't get any email. Uma Gowda needs the data again on this email ID. Please ensure that everyone has the data, or else you will not be able to follow the later on exercises.
It's better to do along with me so that
Yeah, and please try to keep us work with the same pace so that you will be able to get a feeling of what's happening in currently in the data analysis. Okay. What did you receive the data? Please forward the data to Uma.
Forwarded, sir. Forwarded.
Okay. Everyone, please respond whether you have received the data. Vishwa has not received the data.
You can communicate with me to the KSTA privately in the chat box so that I can communicate with them. I will send you mail.
Please, Vishwa, please communicate to KSTA about if you have not received the data, and also provide your email ID so that quickly we can send you the data. Vishwa, please write to KSTA in the chat box. Select KSTA and inform your email ID so that you will get the separate data separately. Okay, now we assume that all of you have got the data because you are not responding yes or no. So we will proceed. In case anyone still has a problem, please type it. We will wait for you, or else we will proceed now. And we will ask questions in between. So you have to follow what's going on and you have to answer the questions. Okay. So please be ready now. Anindita, I think you can continue now.
yeah, those who have got the data, read the data in CSV, run the data, and just print the number of columns
So you,
and the number of
Anindita, you have to show them how to read the data. What is the command we use?
yeah.
Okay, and
Yeah.
let them type also in their R console, and then let them execute line by line. So they may
Yeah.
not be able to write big codes themselves because they are just starting. So they need some help. Maybe possible you can also send them the codes so that they can copy paste and try to execute.
Okay, fine. What
Have the codes, yeah.
these are simpler codes which you can type easily. When I'll come to more detailed one, I'll not expect, but I'll give you the command to read in CSV.
So all of you please adjust your R window in such a way so that you can keep it beside your Cisco WebEx window and look at the screen and type.
Okay, these are simpler ones you can type because then I have to stop sharing and go back to paste it there. So it's just we can write data or input data, whichever name of the variable we can
No,
assign.
follow the same variable name what you have written.
You
So
can
that,
follow it now,
yeah.
but you are it's not compulsory. You give it accordingly, but just to follow this session, you give the name so that you can follow easily.
Also in the break, when there is a tea break later on, please share all the codes with them so that they have something to look into, and instead of typing so much, they can quickly copy paste. to run that.
Yeah.
Yeah.
So
So
when you
yeah,
have
please,
the
please go
data
ahead.
frame,
Yeah.
uh, I assume that everyone has a data frame, this hard data or in case anyone hasn't got that, take any other data just to follow along.
The file
Then
name is art.csv. Okay. I hope everyone has. Okay. Yeah, please proceed. Yeah, proceed.
yeah. So we'll read the data, giving the command read.csv, and within double quotes, we are giving the name of the data set. The data set name here is heart.csv. So after writing the command heart read data.csv in double quotes heart, what we'll do, we'll take the entire code and run it. Either you select the entire code or just click at the end of the code and click to run. If you don't want to press run here, enter control, just click on control enter to run the code. There are two ways to do it. So follow along how you want to do. Now, after reading the data, we want to view the data. Already I've actually run the command. When you say view data, don't write in view in small letters, write V in capital letters, otherwise it will not run. VIEW view data. So what we do, this is the command to view the data in R. So we get the data opened here and we can see the entire data set here. We can see the number of categories the data has, the number of rows and the number of columns. Either we open it here and check the number of rows or number of columns, or there are other ways also to check the number of rows and number of columns. We can simply write print n in within bracket n column data, print n row data. So when we use this print n column data, we get the number of columns. I'll just show you, I'll run. And when we say print row update, this will run the number of rows, how many rows and number of columns. I'll just keep it here so that it becomes more prominent. So we want to open the data, we want to see the number of rows and number of columns in the data set, we want to know the content of the data. This is the way to do it. Now we want to also know what are the labels of the data, what are the category names of the data set. We can see what are age, then sex, then chest pain, then rest BP, cholesterol. These are the categories the data have. We want to see directly the categories, then we can just type names under bracket data. So using this, we can see the names of the data set here. Here we can check the X, age, sex, chest pain, rest BP, cholesterol, max H. I think this is maximum heart rate. This is low calcium content, thalassemia, AHT. These are all the contents of the data set. We can directly see that through names data. So this is for viewing. This is for seeing the header of the data. Now, I hope till this you have opened the data set, you have seen the rows and columns, and you know the content of the data, what is the data which you are working with. So knowing the data set first is the requirement. Now, since we have the data set, now let's select only one variable to work with it. Now, to work with the one variable, what do we select? Age, then give a $sign and data $age. So we are taking just the age in it, or I'll just run it. Just you can type it along data $age and run and see what is the result. We just see the age of what are the ages of the entire data set, the category, we see the age. And we want to subset only age and we want to take that data. So what we do, we'll take a variable name, then we'll subset data, select equal to age. You can select any other variable, you can select age, or you can select FPS, cholesterol, any other thing, whichever you want to work with. Because of so many categories you don't want to handle so big data set. You can just subset it, crop it in order to get a smallest data set. So what we do, that subset data, comma, select equal to age. So run it. And then data set. So this is the data set which we are getting. So similarly, as we have done for age, we can just to show you, we can just change into calcium and then run it. Do it along so that we'll know how to subset the data set, how to work with the data set. So this is the data set. Here we get a data set NA. So these are null values, and I'll be also dealing with the null values later. First, I'll show the data frame, how to work with the data frame, and then I'll come to how to handle null values also. So this is the subsetting of one column. Now we don't want a single variable, but we want to work with multiple variables. Now, if you want to work with multiple variables, we'll do the same thing as we are selecting only one. Here we'll do a concatenation function and take C, then the names of the column names which we want to select. Here we are taking calcium, thalassemia, ADH. So we are taking these three categories here and we are subsetting our data using the three categories. So I'll just give you some time. Please type out temp df. This is a data frame I've taken, subsetting the data and selecting three columns out of it, that is calcium, thalassemia, and ADH, and we'll run it. Okay, what we this is because already calcium is taken out. So what we'll do is we'll again run the data frame. So we have the data frame, and from there now we'll run. So already if you have done some operation on the data frame already, and you're taking the same data frame already, that data frame has only calcium category. So you cannot take out calcium, thalassemia, ADH from the same data frame. So you have to take the data frame again. And because I already have taken a column out of it, we have selected calcium, we cannot take the same data frame. So I've run the data again in order to select the three categories here. So again, we'll type temp f. This is temp df. Okay. So we have to be careful in what we type also, because it's important that there should not be any spelling mistakes on that. It should be exact matching. So here what we have done, we have extracted the three columns which we need. Before that, using select calcium, we have taken only one column out of it. Now we are selecting three columns to work with the data. Now, because we have named it as temp df here, to further work with the three columns, we take it further as tmpdf data frame. So this should be how we take, because we have selected, we are given the name to work or proceed further, we'll give the same name. We'll not give other data name because we have already extracted the data out of the data frame. Now, this is for selecting one variable. This is for selecting three or many. It's not only three, take as much you want. Now we want to remove a variable. We want to take the entire set, but one column we don't want. So what we will do for that, what we do, age dollar data dollar age. So what we do here, we give it as null. And let's view the data set. I'll explain then. So what we are doing here, that we are removing the age from this data set. Is it there? No. Which was already there, it is removed. Now what we do here, we are taking out age. Data set dollar age, we are just taking age and assigning it as null. And we are doing it, we are taking it out. When we are taking out the data set and view the data set, that data set is gone. So when we see the data set again, the age category which was previously present is not there. So while we want to select a few columns which we want to work with, and also we want to remove some columns which we do not want to work with, we can do such data manipulations here. Now, what we are doing here is we have assigned null, but there's other way also to do it. Like we are using subset. Now here, as you said, seen before that select is equal to calcium. We have selected calcium. Now what we do, we deselect calcium. How do we do it? We'll put a minus sign is that we don't want calcium or any category which you don't want. So what I'll do here, then view. Let's see if it is present. It's not there. So this is the way of selecting and not deselecting. Like when we put calcium, select equal to calcium, we are selecting the only column which is calcium. Now, when we say select equal to minus calcium here, then what we do is we are telling to exclude calcium. That particular column is getting excluded from the data set. Now we are able to view the data set. Similarly, when we want to remove multiple variables, what we do is the same thing, we'll deselect it. Now we don't want calcium, we don't want thalassemia, we don't want ADH from the data set, but the rest of the data set we want to work with. We don't have any other problem to work with the data set. So what we'll do, we will subset the data, select equal to minus C under brackets, what are the column names which we do not want to work with. That is calcium, thalassemia, ADH. So let's run it. And let's view the temp. See, these categories are gone in the file. The new file which we get, these are not present at all. So this is the data frame, how we work with the data frame. We can also create a data frame here, as I have shown you. The Excel sheet which you have downloaded and which you have imported is also a data frame. So in that data frame, you can find out the number of rows, the number of columns. You can select only one variable to work with. You can select multiple variables to work with. Either you can remove one variable through null, or there is another way to do it, select minus, and you can deselect multiple variables. So this is the way to work with the data frame, to either select a particular thing or deselect a particular. So let me know if you have done it, you've understood what we have done here. Let me know. Anyone can respond that you have followed till now. Can I get any response that you have followed till now, you have done till now? What we have done till now, I'm just summarizing. We have taken a data set, we have imported the data set, and that data set has a number of columns. It has a lot of number of columns, but here what we are doing is we want to select a particular column to work with. Maybe a particular column or few columns. We do not want other columns. So we are selecting those columns and working with only those columns. Or we are deselecting certain columns and excluding those columns and working with the rest of the data set. This is what we are intending to do here in the data frame. So I hope you have done at least some part of it to know how it works, and just give me some response that you understood what I tried to tell you. Did everyone get it?
Request participants to reply.
Yep. Just if you understood the thing, why we have done it, what kind of intent we are doing here, why we are doing this, why we are selecting some, why we are leaving some part, we are deselecting some. It's just because we want to work with certain data set and other we do not want to work with. So this is where this comes in. So when you have a data set, you have some data set, then try doing such manipulations or try doing such things. And when you will work with some data set, you'll have a grip on the data, what you want to work with, what to exclude, what to not take. And so this is the data set which we have taken. it had so many variables, but we have done certain operations, and after that we are left some assets. So this is the way to do it. So what I'll do, this is the data frame. I'm deselecting and selecting data frames. It's quite easy. Just I'll copy it and keep you during some break so that you can just copy paste and do it. But for now, just try to type some of it, like just import it and select only a column and try to do for one column. And I'll proceed further to the CSV data set. This is also how to work with the data set. Some scatter plot just to see the data set properly and doing some of the things which we want, excluding others. So you have the hard.csv data set. Here I'm taking header equal to true. Here, when we say header equal to true, it means that when we see the data set, this is the header. We have certain values, name of the values given. So here we are telling graph the R that this Excel sheet or this data frame, the first line, it has a header. We are just giving the information to R. So when you see such header equal to true, we can directly say read.csv hard dataset, or we can also specify header equal to true. So there are many ways to input the dataset, to read the dataset. So this is also one. Now this is the dataset we have. It refers to the second column of the dataset. Now we know age is the second column of the data set. If we haven't removed age here, we have actually removed age here, but the age was supposed to be second column. Here we have removed during our data manipulation process. So it's supposed to be the second column. It is not here, but anyway, I'll again read the data so it will be there. So what we do, we want only the age part of it. So what we do, age equal to data, comma 2. Comma 2 is the number of columns. If we say number 1, then the number of columns present in the data set there. So we'll run it. Now we want to plot age. We are simply plotting it just to see. Now we can set the limit also of the y-axis. What limit we like, where we are seeing from 30 to 70 is the age limit. Now we want the graph or the plot according to us, which we want to see or we want to show in our graph. So we can just set the limit. First, the command for it is plot age, comma xlab index, ylab age. We can just give the name of the x-axis and the y-axis, and we can set the limit as we want. But seeing the maximum and minimum and maximum here, let's we have already plotted. Let's set a limit and plot from 50 to 80. Just plotted. I'm just showing you or giving you a brief view that what we can do with the data. We have inputted our data. We have a data. We can select a column. We can select our rows, and we can exclude something, and after that we want to see visually how the graph looks like, what are the scatter graph look like. We can later see we can sort out the data also. Here when we see the sort command, like we just give the function as sort age, then we give the x value, y value, the limits and the name of the y value, and we set the limit. Then when we run it, we can sort the age. So this is called the sorting of the data. We have created a scatter plot, but we want to sort it accordingly, and this age is sorted. Now, see, we are creating a box plot setting the limit as 0. I'm just showing you, you can change the limits. Like if there is a plot and you have already, it is inbuilt that it is taking the limits of the data, but you want to show it in another minimum and maximum limit. So these are the ways to do it from 0 to 80. Now we are just setting the limit. We can change the limit. Now come to summary. For any data set, we want to know the summary. Then only we'll know the distribution of the data set to know the data set better. So when we come to summary, it will give us the minimum, first quartile, median, mean, third quartile, max. Now in case of box plot, I'll tell you what is denoting here. Now this is the whisker in the box plot, and this is the minimum limit, this is the maximum limit. Now when you see first quartile, I assume that you know, but I'm telling you once again, this is the quartile. This is the first quartile. In box plot, the middle is not the mean but a median. This is representing median here in the middle, the line. This is the third quartile here. So this is 75 percentile of the data, and this is the maximum limit. So in box plot, we are seeing the summary of the data set, but in box plot, we can visualize the data set more easily, seeing the minimum, maximum, the median of the data set, where the 25% of the data lies, where the 50% of the data lies, where the 75% of the data lies, the age group of the data set. So we know the maximum the data set is lying between 40 to 60. 75% of the data is under 60. So we can just interpret it through box plot. We can summarize the data. We can take the first quartile, median, mean, and maximum. So we are summarizing the data. This is the input, but we can do it also of our own. Since it's data entry, we are taking a Excel sheet, but we'll also do some manual data entry so that if you want to do it hands-on, easily just type it your own values and do it along with me. So grades. Now we are using the concatenation function. We are just assuming that there are 4 students who are getting certain grades. So just you can type it on grades equal to C under brackets. Just write certain numbers. Here I have given some 4 numbers. So we are assuming that 4 students have got certain marks here. Now we'll run it. So this is taken as the input. So sort grade. So it will come as a increasing order. So it is sorted accordingly. Summarize grade. So we are getting the maximum, minimum. This is a very small value, 4 values, but still just in order to do it easily, we can take that summarize grade. And now what we can do is, in case you are not working with the data set, hard data set, you just type it along and you'll also get the gist of what I was talking about. So this, when we do the summary of grades, you will get the summary. Then if you want to sort it, like only you want the data set, the plot between 70 to 100, then run it. So when we want to plot and sort the data set, and we want to set the limit from 70 to 100 marks, those who have got only, we want to see those students who are below that marks. We do not want to plot the students marks. Then what, this is the command for that. Plot sort 4 grades. This is the name of the grade. I have given another grade, but take the same grade you want to do, just follow it along and plot, sort it, and set the limit of the data set. So here we are getting, when we are sorting the data set, we are getting the points and the connecting lines between them. So 70, from 70 it's starting, below that some data set is there, but anyway. So these are the data set graphs which we are getting here. So there is a summary function which gives the summary of the data set. When you get the data set, you want to know about the data set, you can type on summary and get it, but you can do it yourself also in R. How to get the summary? You get the sum of the age. Sum equal to sum of the age, whichever age you have given here. Okay, here I am taking age of the data set, hard data set. So in hard data set, those who have the hard data set, do it with hard, or any other data set you can do along. So sum of the age, we are running the sum, the total age, then length, how many people are there to get the mean. So sum divided by age is mean. So we are getting the sum. Either this way it is there, but there is also inbuilt function. So we'll get the same thing. So I'm just telling you, either you can do it manually, there are inbuilt functions also, but just in order to see how R works, do it some bit manually, so you'll get the process. Now we want to trim data set, like we have the age data set, but we want to trim the data set 10% only. So when we want to trim the data set 10%, we'll say trim equal to 0.1 and then run it. And when we trim the data set 10%, the mean increases a bit. And here again, we are trimming the data set 8%. When we want to trim the data set 8%, we'll give trim equal to 0.08. Then let's see if the mean changes. It's a little less. So either do it manually or use the inbuilt functions. Then range, it is also an inbuilt function. Range of the age is between 29 to 77. In our data set, the minimum age is 29 and the maximum age is 77. Maximum information how to get from the data set. And interquartile range we can get from the box plot also, but in case we want to know the exact number, it is 13. Now we want to, the again summary of the grade. Now again run some grades, just give some random numbers, you get the summary. You want to know the variance. Variance is square of standard deviation. Variance of the grade is 164. Standard deviation, just giving you functions how to get more from the data set, get more information from the data set when you get the data sets. Now the same thing, square root of variance is standard deviation. You can do the square root, or directly you can just get the standard deviation function. Age trim sort age. We are sorting the age here. Median of the age. I'm just going through that. Just you can type randomly one or two, give some random grades, find the median, find the mean, get the interquartile range. When you do it, you will know, okay, these are the functions which are there. So in case I have a data set, I can go through these functions and get more information out of the data. So we can do these things manually, and after doing these things manually, I think I didn't run the whole thing. When you run the whole of it, which manually it is done, you will get the entire thing. Like if I run entire, I'll be able to get the origin, which has mean, median, range, interquartile range, standard deviation. So this is the origin. So we have a data set. We found out the summary by direct summary command, but we can also do it manually. We can get the mean, we can get the median, we can get the interquartile range, we can plot a box plot, and it gives maximum information to know the minimum of the data, maximum of the data, median value, where the 25% of the data lies, where the 75% of the data lies. So the entire list of the data can be achieved through these commands. So did you follow me till now? I hope people are listening, they are doing the demo. And did you follow me till now? Let me know. I assume that some people have done it, some are listening through mobile. So, okay, Akshita has written yes. Thank you, Akshita, for responding. So, these are the things which is in data frame which you can do in CSV files we can do, and also if you're typing it along, also I've shown that if you don't have a CSV, in order to learn, you can just type it and do the same functions simultaneously. Just to get, if you don't have a data set, just type it your own data set, and if you don't have CSV data set, then type your own data set here and do the required thing and get the gist of the data. Now come to the categorical data set. Now I have shown you that data set has some categorical values, like in case of thalassemia or in case of ADH, yes or no. So these are categorical data set. So what I'll I'll read the data set. So this is read.csv hard data set. Now we are interested in thalassemia data set, which is 14th column. If I view the data, if I just type in view. So I'll be able to view. And now you see the 14th column has thalassemia. Thalassemia, there are fixed, normal, reversible. These are the three categories, or there are more categories. I'll just fixed, normal, reversible. There are three categories of thalassemia here in the data set. Now this is a categorical value. Now we'll make it as a table, thalassemia. So we are just extracting the 14th row, 14th column, which is thalassemia, and we will run it. Thalassemia equal to data under square bracket, comma 14 is that extraction of the 14th column. Now we are taking out a table. Now in table, what we are getting the number of these categorical values. Now the number of fixed is 18, number of normal is 166, reversible is 117. So this is the information we are getting to table. And then we want to count table thalassemia. We want to see the total number of table counts. We have to say count. But here what we are doing, we are finding out the relative frequency. Now relative frequency also we can find out. We can do other things also along with the data. But first we'll try to plot the bar graphs, bar plot or pie plot of the data, so that to use categorical data, you will have a visualization thing, like you'll be able to see the data in a box plot or in a pie chart, and you'll be able to get the summary of a data through visualized process. So what I'll do first is I'll come to the plotting, but anyway, just names okay is there. We'll just come to the plotting. Now what we do is bar plot here, counts column equal to rainbow 3. So here when we say rainbow 3, we are just giving a color choice of 3 colors here, because we have 3 data set, fixed, normal and reversal. If we had more, then we could have given any other numbers here in 3. Since we have 3 categorical values here, we are giving 3. Names dot argument equal to names, and main equal to thalassemia bar chart. Names we have specified here as fixed, normal, reversal. So we are taking these 3 names, and the main is the name of the chart which we are given, thalassemia bar chart. So what we'll do here, we'll run this. Now we got the number of fixed, normal, reversal categories in the form of a bar plot. Now we have got the same thing in the form of table, but doing the bar plot, we can get a visualization process. We can get a visual effect. We can see visually what is the highest number. We can normal as the highest number. It's very clearly visible. It's pie chart also. When we run the pie chart, here we see the maximum percentage people have normal, and fixed is the lower percent of people having that. So same way, I think third is some the categorical variables. We are taking a categorical variable here, and we are trying to do analysis on it. First, to see visually how these categorical variables are distributed. And let's take some other categories. Data comma 3 means take the third column here. If it is comma 14, it was taking the 14th column. So this is how you will select a column. There are various ways of selecting the column. In r.data frame, I have shown you how to exclude, how to include the column. This is also one of the way to take only the third column or fourth column. How you want to work with the data, with what column you want to do your analysis on. So here also we are creating a table of gender. We haven't run the data set. Okay. You have to run and then get the value now. 0 and 1. We are assuming 0 is female and 1 is male here in the data set. And we are also specifying the name as female and male. When you take this data set, specify the name. So these categorical values will come as names and as table. So gender, if female is 0, is come as female 97, male is 1, will come as male as 206. So this is the way to deal with the data. Now here we can also see the bar plot. Here also, I think rainbows 2, I think we can give rainbows 2 because there are 2 categories here. We have to change some of the, okay, I think other part have come up. So whatever the colors you have, you just specify and give. I don't know what mistakes it's happening, but the gist is this. You give the rainbow number, color number, you give the name of the categorical variables, you give the main is the name of the main heading of the graph which you want to give. So heading will come up here in the main. This is how we are dealing with categorical data. I'm showing you just a visualization here because I'll come to the shape of the data here because I think at 12:15 there was supposed to be a tea break. So in 10 minutes I'll complete that, and after that you can go for a break and then come back a little later. So this is the read.csv file. Again, we are taking a hard data set only because in this session I'm taking hard data set only in order to show the demonstration. So this is the data set. For later sessions, I'll be taking some other data set, which is inbuilt. So there's no need to download from anywhere because I had to show you how to import from Excel. I have tried to get you Excel file from outside and then to work with the Excel file so that you will know how to work with the CSV data. But in GRASS, there are so many inbuilt data also present, which we can work on, which I'll be showing you later as the day progresses. This is the data. We can attach the data because we name the data. Attach means if we say data, the same data will open up. We are attaching the data to the variable. So we have attached the data. If we call the name data, so many data set has already opened up. Now age equal to data set 2. We are taking the second column here. Histogram of age. This is the histogram of age we are getting from. Now when we have got the histogram, we have an age data set. Now we know the frequency. Like we know that about more than 60 people are between the age of 50, from 50 to 60, about 60 people are in the same age, about 55, 60 people. From 40, number of people from 40 to 45 is present. So we can categorize it through histogram. What is the frequency of the data set? Like how many people are belonging to which data range? Like we know from 55 to 60, at least 65 people are belonging to that age group. Just by seeing through histogram, we can know the distribution of the data set. Now there are how many breaks here? If we increase the number of breaks, let's increase the number of breaks and see the data set. It's going to be 10 breaks. Let's give it a 5 break. Okay. This is 5 breaks. So when we break down the data into 5 breaks, then it is more visually impactful because that time I had difficulty to make out in what age group what is the frequency of people. But when we have lesser range here, like we know from this graph from 50 to 60, about 120 is the number of people here in the data set, which has the age between 50 to 60. While we have a 10 break in histogram, 10 bars, then it is making me increasingly difficult to analyze visually through the data set. So when you also try to analyze the data set, and when you see through the data set and see the number of breaks, if you see that 5 is a convenient number of breaks in the data set, give it 5, 6 or any. If giving more number of breaks as 10 will make it increasingly confusing to analyze the data, or more, if I give 20 breaks, of course it will be more confusing to know the data. So plot it accordingly. There are so many functions available for you to go through the data set and doing it properly. And box plot. Now, seeing histogram, we've got information about the data set. We know that, okay, from 70 to 80, there are very less number of people. Maximum people in the data set are between the age 50 to 60. Then second is from 40 to 50 and from 60 to 70. But from 30 to 40 also, there is almost 20 people or so. So we've got a list of the data we have through histogram, and we'll just look at the box plot and see what it is giving representing. This is a horizontal box plot here. So just keep it according to yourself. If you want to give a vertical or horizontal, the previous one I've shown you a vertical horizontal plot. And here in vertical plot, here in horizontal, you can easily make out which is the median, which is the first quartile, which is the third quartile here, which is the minimum, maximum. So these plotting, this visualization can give you a summary of the data set just by seeing it. You can summarize the data set, you can do other things, but visually also you're getting a lot of information about the data set when you are just seeing it in a graphical form. So I think here I've shown you about data frame, to include a column, to exclude a column. Then in CSV, I think it's also about setting a limit to the box plot, how you can visualize the data set. Then we have seen the categorical data set. Just I think one is enough. In thalassemia, 14th column, what we have seen, that we have seen a bar plot, how to see the number of categorical data set, what is the numbers, how to work with the categorical data in data shape. What we saw through histograms, how can you visually see and tell more about the data set. Summarize is always there, that you can get the summary of the data set, minimum, maximum, then mean. But also visually, if you see, then it gets you more information and you get to know more about the data. So we'll take a break and then we'll come back and we'll again go through the data manipulation. So for now, I'll just stop sharing. Is it okay?
Now it's 12:25.
Yeah.
We'll be having 10 minutes break. 10:35, you can all come back. Meanwhile, ma'am, can you please share the scripts? Few of them are asking scripts also.
Okay, okay. What time you said to come back?
10 minutes.
Okay, 10 minutes. Okay.
12:35. Yes.
35. Okay. Okay, I'll share in the chat.
Yeah, fine.
I think everyone has come back from the break. Yeah, I'll be sharing the script also. First, you'll not be able to know what I'm doing. First, I'll give you a list of what I'm trying to show. Then I'll give you the script for the next session also. I'll just go through the script and then I'll copy and paste in the chat. And I think those R scripts will be provided to you also in the R file, .r file. After I'll explain you the codes, I'll be giving you during the breaks or any other time. I'll copy and paste it.
Hope everyone is back. Ma'am, you can continue.
Yeah. I'll share. The screen is visible.
Yes, ma'am.
Okay. Now there was also how to import SPSS file in R. I've shown you a screenshot also how to import, but I'll just show you how. When you go to file, I'll just give a new script. File, then I'll come to import data set from SPSS, from SS, from Stata. I'll show you from SPSS here. From SPSS, the statistical software. So when you have that, there's a library called Heaven, which is already there. In case you do not have, then you can get Heaven, but in a latest one, you will already have the library installed, so there is no need. So we want to import the data set. Now we'll browse. What you can do is, like if you are working with SPS data set, then you have the data set. Those who are not working with SPSS data set, you can just Google it out, SPSS data set. There are so many data sets which are freely available. Download any one of the data set in order to do it along with me. Download anyone, because I've also taken a random data set which I got it freely. So browse through it. First, you download just in Google, say SPSS dataset, and get one dataset just which is freely available. Get it in your R file where you are working on your working directory or any other place from where you can browse. So get that file, and after getting that file, we can browse the file and we can open it in R. So just I have survey data set. I got it from Google. This is a SPSS data set. Similarly, you do it SPSS data set, any data set. Just in order to learn how to import, just take that data set, browse through it, open it. When you open the data set, you see the code preview. There's a code preview written here. Library Heaven survey data set. So when you view that, either you copy and paste same thing, just copy and paste in the console. So what we can do, we can copy and paste it here, or it is already there, so we'll directly import it. When we import the code here, then what we see is that the data is getting imported. So this is the way to actually import any other data set. Just browse it through the data set and open it. And after you have browsed through the data set, you are able to see the data set also, what are the content of the data set, and then import. I hope all of you who have laptop, you can go through that SPSS dataset or any other dataset, Google it out, get a dataset, download it, keep it in a folder, then browse the dataset and import it in R. So when you've imported in R, the data is there as a R in our format. You can do data analysis on that in any format. So this is the way to work with any other data set. So I'm just waiting for you for 2 minutes. Just you please Google it out, find the data set, find any data set, and try importing it. After import, you tell me if you have imported it. And similarly, same way, you just get other files. If you're working in this data, in this software, statistical software, you have those files, then import your own file in R. So when you know to import it, then you do the same analysis process which I'm teaching you how to do the analysis. So you can continue in that. So just click on import to import the data set and to work with it. So right now I'm not importing, you just click on import and get the thing imported. You'll be able to open it in R and you'll be able to open and work in R. So there will not be any problem in that. Are you able to see my screen? You are able to see R Studio? I have given you all the codes. So please copy and paste those codes and run through when you have time. Now only you can do it, or I'll actually go further and explain you other things. So you can come back and try copying the paste, copy and paste, and then see the histogram, see the visualization in R. And you have a data set. How you can visualize the data set in R? What are the summary statistics you can get? What are the information you are getting? Just do it yourself and get those information. I'll proceed. I'll stop sharing this and I'll share my PPT. Now I'll stop sharing. Clear till now? You can just message me in chat so that I can see some response that till now at least things are clear from your side. Anyone? Please some responses.
Madam, if you
Are
want
you
all of
people
them
there?
to come on video, I can make them.
Okay, they can type in chat now if okay, it's
Yeah.
clear. Like I'll be able to get some responses that some people are doing it. Because, okay, thank you for your responses. Okay, thank you, Murli, for till now what I've done. It's clear because I'll come to now null values. Like if you have null values in the data set, how to deal with that. You have a data set, it's all clear. You have categorical values, how to do plotting, everything is okay. But if the data set contains values which are missing, how to deal with the missing data sets? I'll be coming to that in the next session, next lecture. So what I'll do is I'll share in PowerPoint. Okay, this was the data set which was required in the previous session, but I'll move ahead now. Now, missing values. When you have a data set which has missing values, it is represented in R as NA. NA means not available. Values of any type can be missing and represented as NA. And importantly, R knows that NA means missing values and treat as NAs accordingly. So it knows NAs are missing, so it's treated accordingly. And operation that involve NAs are themselves NAs. Like if you sum for NA, it is NA only. You cannot operate on missing data and get anything but more missing values in return. Try operating on any data which is missing, you will get an answer of NA only. So R does not respond to NA. This also means that if you compare two NAs, you will get NAs because NA is missing information. So it is, we can say is.NA to detect if it is a NA value, or is.nan is also showing if it is NA value. So NA can also be integer in a character in the sense that where NA is missing in an integer, it is an integer NA. And when NA is missing in a character value, that is in a categorical value, then it is a character NA, not available data set. So in this side, you can see there is a data set where this BMI, hypertension, I think cholesterol, these all have NA values. So many NA values are present in the data set. So if you have such a data set with a none value, missing value, then what you will do? Now to deal with the NA value. Now there are various ways of dealing it. Either you delete those rows with missing values, or delete all rows, or delete some rows, or you change the missing value to a value, or what you can do is change a specific value or make it to 0. And there are other functions in R, which is imputation, which substitute values to a data frame, which will come to this, but we need R packages for that. And I'll tell you what are the packages to get to deal with the missing values. But before, I'll tell you simple methods also, which can be done to deal with the missing values. But these methods which are deleting can lead to data loss, can lead to bias also. Bias in the sense, if there are some data which has urban population and rural population, and most of the population in rural, the data are missing, this is NA value, and in urban the data are intact, it is there, data is present, then most of the values which we'll get is of urban and rural population, the data will be missing. So it will lead to highly biased analysis, because only one section of the population is represented and the other sections are missing, and out of a few numbers of the section of the population, the result of the analysis is being carried out. So it can lead to highly biased result also. You can replace the value as an average value also, like you have a number of rows, number of columns, and you can replace it, the missing values, with a average value or mean value. But sometimes this is not a viable option, that is why we go to imputation. In our, we use packages, different packages. One package is mice, which is multivariate imputation by chain equation. So these are the packages which are available. When we use those packages, we can fill in the NAs with the more relevant value and do our analysis, carry out our analysis there. So there are packages. So R has a lot of packages, because when I talked about imputation, here the packages are there, which is available, and R has a lot of collection of packages, and it is available for download and use. And when you install R Studio, it has a lot of default packages already. Already it comes with default packages, but still there are some packages which we have to install. Now, when you see R, you will be able to see the file, plots, packages, and we can update the packages also by clicking on this install. We can install the packages which we want to install, which is not available. We can see the available packages which are already there, but if we want to install new packages, we can use this install button here and install our packages. Or either there is another way, install dot packages in under bracket, you write down the name of the packages you want to install, and from directly you can install from typing there in R console. Or either you can call out the library after installation, call out the library for certain packages, and then you can work with certain packages in R. Now you can also update those packages which are there, but for after some time those packages can be updated. So these are the R packages which we'll be using. So we'll come to the demonstration of missing values, how to deal with missing values, what we can do in R. I'll be giving some options. There are, of course, many other options which you need to explore and do it. I'll open my files and then I'll share the screen. have shared my screen. Is it visible?
Yes, madam, visible.
Okay. Now, this is to see for missing values. So, if we add anything to missing value, it will be missing NA plus 5 NA. So, to check if a value is missing, use function is is.na. Is.na, if we just run it logically, it will come as true because this is NA. If we say is.na 4, this is the integer, it's not NA, it will come as false. So through logical functions, we can check for NA. If it is true, of course it is NA. If it is false, it's not a NA. That is non-applicable value in R. And R can easily recognize it. So just it's simple typing which you can do. We can assign X and we can just concatenate the function C under bracket, write 1, 2 and give some NA value, NA, or just how many you want to give a NA value, missing values, and just create a small data frame yourself. And then check for it if R is able to recognize it through logical function if it's showing you that it is a NA value or it is a NAN value. So just I'm running this. Now it's assigned. So we'll see is.na in X. False, false, true, false, false. So this is a integer. So it will come as false. 2 is an integer, false. NA, this is true. 10 is an integer, false. Then 3 is an integer, false. So this is the way to check for NA. So please, you people, because you this is a small thing, 1 minute task. So just try to give a data frame, give some NA values in it, and check it through logical function that if NA is present or not. Just check it because you don't have to do it with a data set now. Just check it with a logical function. What kind of result are you getting? So NA function we are getting as false, false, true, false, false. Now same if we put NaN 1, 2, NaN, Na, 4, what kind of a result we get? Now this is the input is Na.x. False, false, false. Of course, this is 1 is an integer, 2 is an integer, 2, true, false. So NaN is also considered as a NA value here, and it is considered true. True means these both are NA values, true and true. But the same if we do for NaN, let's check the result. False, false. Of course, 1 is a integer, 2 is an integer. NaN it is showing as true, but Na it is showing as false and false. So NaN only shows true for NaN values. If it is Na, it doesn't show. But in Na, is.na shows true for both Na and NaN. In case you deal with such a data, just I'm telling you how to check with the function what to do with it. But mostly if it's Na, just check with is.na. Just check through logical function which is true, which is false. Once you identify, you can remove it. Removing NA values. Let's give the name as bad. Is.nax. We are just seeing which are the value which is NA. So we can check what it is bad, what it is giving. False, false, true, true, false. X is false, false, true, true, false. So this is how it is recognizing NA. Now what we are doing, now X will not take which is NA. So it will exclude the bad results. So what X is doing, excluding the NA value, and it's only giving the good result, that is 1, 2, and 1, 2, and 4. This is the X here. 1, 2, and 4. NaN excluded NA, excluded 1, which was true, 2, false. 2, it was false, and 4, it was false. So only those values which are false are being taken, and NAs are excluded. Similarly, there is also a function called complete dot cases. Now first we'll run X and Y. Here we are take any numbers and put NA. Take any other whichever combination you feel like, just in order to experiment, take some numbers and do this analysis. X, run, Y, run. And now to get complete cases of X and Y. This is good. So we'll see which is good. 1, 2, 3, 4. 1, 2. Where is 4, 5? Sorry, 1, 2, 4, 5. So here also, when we take complete dot cases, the NAs which are not necessary, which we don't want, the missing values, not available values, are excluded, and only the good values are being taken here, which are good, are being taken here. So 1, 2, 4, 5. The good ones are kept, and the other values which are not required are NAs, which are excluded. So I'll want you to just type some values and use complete dot cases. If it is not, you have not taken Y value, just take X and use complete dot cases, and then run the command and see if you are able to exclude the NA values and get only the good values here. Good, I have just kept it as a name, whatever name you want to keep. You can keep just for consistency while practicing, give the same value. While doing it yourself with your data set, you can change the names and do it yourself. Now, this is removing NAs. I've taken a small data frame which I've created of my own, data set of my own, and I'm doing just in order to show that this is the way to exclude certain values and to just take out certain numbers which we want for our analysis, which we want for our own study. So till now, is it clear? People got how to remove in a small data set created here. Did you get how to remove the NA value and get only the values, integer values or other values which you want? It's like use the function and get the results. I think it's clear to you all. So I hope it is clear. Now, let's see. Here I'll just, before doing replacing with, I'll just show you the result. If we have a vector with NA or any other data set with NA, if we run it, what kind of result we get. Now this has NA. If we sum it up, let's see the result. It comes at NA. Just to see, with NA we cannot do any analysis or we cannot work. That is why to get rid of NA, what are the things which we can do? Just this is the way to ignore. Now replacing NA with 0. This can also be an option, but I'll give you different options to replace the data set with. So here we are taking, in X we are assigning 1, 2, NA, 4, NA, 5 not applicable. So 1, 2, 4, 5 are only the data sets and other are NA. So we want to replace it with 0. Let's see. Is NA X, assigning it to 0. Let's see. X. Okay. So what we are doing here, we are taking X and we are taking out NA. Which are the values which are NA? This is the function for that. Is dot NA X. So we are extracting the values which are NA. It's getting the value which is true for NA. And those values it is assigning as 0. So when we assign those values as 0, the value where this is NA, 1, 2, 0, 4, 0, 5. This is the output we get. This is replacing NA with 0 in a vector or any other. Now, let's load a data set and do it. This data set is already inbuilt in our, so you need not have any CSV value or download any CSV file from anywhere. So we'll just directly load the data. Loading the data. We are taking air quality data here and taking air quality data. If we see the data, there are a lot of NAs present there. So I'll just show you the data before. Okay, I'll run it. Air quality. To see the data, either you click it from here and see the data, or what you can do is write view data and you can view the data. What happened? Air quality data. It's another data, it should wait. The data from the. So this is the air quality data. In air quality data, we have ozone, we have solar radiation, we have wind, we have temperature, we have month, we have day. So this is for, I think, for a month. It's 153 number of data sets are present for ozone, solar, wind, temperature, and month. So what you do is, because data was before assigned to hard data sets coming same here, we can just type in data air quality and get it. First, you do one thing, you just type data and within double quotes air quality. You can take any other data set which has missing value, but for consistency and doing it here for practice, take the same data set air quality. So load the data set. After loading the data set, find the missing value. There are missing values which I have shown you. There are missing values in the 5th row. There are missing in 6th. In 10th also you can see. 11th also it is present. 25th, 26th. So many NA values are there in the data set. So in order to work with the data set, it needs to be corrected. So there is data set which has a lot of NA values, missing values. So first we'll find out which are the NA values, which are the missing values here. So many values have come up. False, 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 false. So which has true are missing here. So here 102, true, false. So this is missing. So through this logical operator, we can know which are the values which are there, which are missing, so that we have a visualization. Okay, take it out as a logical function. Count missing values. Now we have missing values, but we want to know what is the number of missing values. So for counting sum in bracket is dot na air quality. Let's count the number of na values here. There are 44 values which is na in the data set. So we can omit also these na values. It's not a viable option. I'll give you another option also, but I'll show you options which are available, which you can do. Either you omit or remove, find a mean and replace it with a mean, or keep it as 0. Whatever you want to do, you can do according to your needs and specifications. So I'll use omit na.omit air quality. Let's see what happens. When we say omit, then of course this gets omitted. All the NAs are getting omitted. Not a viable option, but this is the option. One of the option. One of the option is to find out the NA. You can just get the number of NA which are present, and then you can omit those values. You can remove those values from your data set. Or you can find the mean. I have removed it from here because in missing imputation, I'll be showing you to do for average also. Like in missing values, in place of missing value, we'll replace it with the mean. And here, replace NA with 0 in a data frame. So we can also replace with a with 0 values. Let's try that. So if you see the air quality data set here now, whichever was missing NA has been changed to 0. Let's check in this data set. This is the data set we got, and this is the missing values NA, which was then changed to 0 here. So this is also one of the options. You can take a lot of data sets are already present. I've taken air quality data set. There are a lot of data set which is trying the data set for missing values. Take data sets. You can actually just for selecting different rows and columns. There are to view data muted filter. I'll be showing you later on. But this is one of the data set which you can work with. There are a lot of data sets having missing values. Try those. Try to take those data sets and see if what kind of results you are getting, and if you are satisfied with that result. Like if you are satisfied with removing the NA, that gives the data set gives you a proper result. Like visualize the data, it will become very less in comparison. If you have millions of data set, just to omit 44 won't be much of a problem. But in case of 100 data sets, if you are omitting 44 data set, your data set will become very small. So in that case, you have to think, like if you have a smaller data set, you cannot omit out, or you cannot make the NAs at 0, because it can bring a lot of bias in the data set because those are missing and you are just replacing with some value. Average is also some options which are considered, and there is also a package in R called mice. So in that package, it's dealing with the data set which is missing. So I'll stop sharing right now and I'll copy and paste it in, so that you just from the chat you just copy it down, paste it, and you can see the data set and find out how to deal with the missing values. So I'll just stop sharing and put it in the chat. Okay. And next also I'll explain and then put it in the chat so that you know what you are doing. This is the code for NA's missing values. So I've given you. So please copy and paste and see how to work with missing values. There's a code. Please check in the chat box and let me know if you are able to access the code from the chat box. If you are working with the data, if you are getting the result, let me know so that I have some responses from your side, and then after getting the responses, I'll proceed. Take the codes from the chat box. First, to check if a value is missing, we are first checking the value if it's missing. Like is.na, which is a function which gives a true value in case of missing values. In case it is false, it's not a missing value. So we are using these functions, and through functions we are detecting if it is true or false, and So using these functions only, we are eliminating the NA, and here we are either replacing it with 0 or we are just eliminating those elements. And eliminating the elements which I've said, it cannot be a viable option in case you have big data, a lot of data sets. To eliminate 40 rows or 40 columns is not a big deal, but if you have a small data set, if you delete it out, you will be not having proper data to work with. So this is one of the option, but it's not option for all the data set, which I think. So you practice this and please let me know, because I was telling the pros and cons. What is the disadvantage of using, like disadvantage of removing NS or replacing with 0? Can anyone answer? Because I've been telling continuously about that. Why we in what kind of data set we should not remove, or what kind of data set it is okay to remove. Uh, Anyone, so that I know that people are listening to me. Can I get some response that I'm telling about missing values? So why we are doing certain operations on missing values, and if we eliminate some rows, some columns, what are the disadvantages? On what data set we can do, just because why we are doing that, on what kind of data set it can be done, so that I know that you've got my point. Okay, loss of data points in small sum, it will affect me. Yeah, thank you for your responses. So I hope you people are doing that. You've got the codes in the chat. Copy and paste and see what kind of results you are getting. Yeah, loss of data points in small samples. If it is big samples, 40 points loss won't matter so much. But if it is small, if we are deleting, it will affect our result a lot. Yes, you people are doing that. You are copying and pasting those codes and seeing for yourself how the data set work. So this is for air quality during breaks or any other time. If you have time, then do it for any other data set. There are so many inbuilt data sets in R, and those data sets have a missing data in a data sets. So just find out and do the same thing and see what kind of results we get and how it is applicable in other data sets also. So I'll share my screen now. So I'm sharing my screen. This is the second part to uh, see the missing data set, and here I'll be doing imputation. We'll be using a package. I think here this package is required. So I hope everyone has R and they have internet connections in their laptop, because we have to install a package which is MICE. The full form of MICE is Multivariate Imputation by Chained Equation. So what I'll show you, if you go to help, okay, come to help, and in search option, I've already searched for it, so it's there. Just in search option, type mice, and after that, press enter. So you have mice, multivariate imputation by chained equation. This is one of the package available in R to deal with missing data. So we have to read through it, what this package is all about. And this package implements a method to deal with missing data. It's already been told here. And the mice algorithm can impute mixes of continuous binary, unordered, categorical, ordered categorical data. So it can deal with all types of data, not only integer, but categorical and other data are also being dealt at with mice. So this is the usage of mice. This is how it works, the code and arguments. We can go through it. Whichever package or whichever you have a doubt in R, just type it in the search and get all the documentation. Read about it and then implement it. Read about the whole thing, what it is trying to do, what it's trying to say, and then use those packages. And for all the packages, these documentations are there. So just type it, read what it is available, and then mice package contains it inspects missing data pattern, imputes missing data, then diagnose the quality of imputed values, then pools, stores, exports imputed data in various formats. So many advantages are there. Now, this package has different ways to deal with the missing data. PMM is predictive mean matching. This can be done in case of integer or any other numbers. You can also go for classification and regression tree for prediction of numbers which are missing. Random forest imputations, these are also available. Mean imputations are also available. How to change it then? Logistic regression, it can be done in case of categorical variables. Lasso regression is also binary categorical variable. This regression method can be done in case any values are present in categorical, then you can go through these logistic regression, lasso logistic regression. Binary means one value or the other, and when it is binary, then it of course shows categorical variables. Categorical, as I've shown, male or female, or any disease, yes or no. So this comes as categorical. So in that case, use these regression values. So first of all, when you have a data set, you have to check the data set and know what it is. What are categorical variables in it? What are numerical variables? Know the data so that in the data set, if there are any values, then missing values, then accordingly you can solve that problem. For a categorical data set, you cannot do the same and same missing value sorting as it is done on another data set. So check the data sets, see if it is categorical or not, do it accordingly. So read through these documentation. For every package, there are documentations here. Go through this, read it, and then apply an experiment and see. In case of missing values, check this and see. So what package is required? First, it is mice is the package. See the documentation, then install. Either you can go for package and install it directly from here, or what you can do is install .packages, double quotes mice, and run it. Okay, updated. Do you want to restart? No. Package message in use. Okay, already it's in use, so there's no need to install. But you people have to install mice. First use install.packages, install mice, then library call the function, the packages, and then you go for the data set. Now, this is air quality data set you can do, but I'm using another data set which is in health. This is I think this is a health data set. So in this health data set also there are a lot of missing values. I'll show you the data set here. This data set is here. You can show the data. Okay. What I'll do is, because I'm not seeing, I'll just stop sharing and I'll show you the data set.
Madam, we will give lunch break at 1:45.
1:45. Okay, fine.
Okay.
Yeah.
So after that, how much time it will require, ma'am, to finish the today's process? Remaining very well.
1 hour 30 minutes. 1 hour 30 minutes. We can.
Okay, fine. So I will give some 25 to 30 minutes lunch break to them.
Yeah, sure.
Okay.
I'll share the data. Till I'm doing that, whatever codes I've given, try implementing that. So that, because I'll be working with the NA values only now for now. So you'll have a grip on that. I'm trying to open my R Studio. It got closed, so bear with me. Just okay. So first, what we do, we install mice. Install.packages undercodes mice. So I'm trying to. It got closed, so I was doing that. You want to restart? So library also will run as mice. So here it is getting, the package is getting downloaded and get installed. So we have to wait for some time. So when you do that, install the packages mice, it will download certain of the packages and install it. So you have to wait for some time and then do it. I'm showing you from the scratch. So this package mice is there. Now we are taking a data set, which is a health data set, which is NHANES. So this is a data set which I'll be showing you. This data set consists of age, BMI, then hypertension, and then is cholesterol. This is a health data set. And here in this data set also you can see the not available data, NA, missing data. So many of the data which are not available. This is only 25 data set. So in case we exclude this data set will be of no use to us because half the data set is gone. And we have half of the data set only for analysis. Now, here look at the data set first. In hypertension, this is first we have to look if it is categorical or not. This is BMI. It is a numerical data set. We can see this age is 1, 2, 3. That means it's a the data consists of kids data set. Then hypertension, it is 1, 1, 1. This is a binary data set which can 1, 2. It can be taken as a categorical data. Cholesterol, these are the numbers. So hypertension data is a categorical data set here and others are numerical. So when you have a data set, please go through the data set, check what it is consisting of, so that you can do the necessary methods according to the data. Now converting from continuous to binary. Now R will take that as a continuous data set only. But if we convert it into binary, then R will recognize that this data set is categorical data set. When it recognizes it, will treat that data set. It will treat the data set as binary categorical data only. It will not treat that as continuous data set. So we have to convert it to binary. Okay, I'll first show you. If we do not convert, we summarize the data. First, we see the data set. So we have a data which is summarized as this. Now we convert this to a binary data set. For converting to categorical data set, what we'll do? Data $sign hypertension. This is the so that R recognizes state binary as function as dot function in brackets data. Now what we'll do? We'll run it and submit. R is running that. Actually, this was run before. That is why the result came in as 8 there. But when R doesn't recognize that binary, then the summary of this data set will be something different. Because I have run the data set before, it is coming as 8. But you will get a different result. What you do first when you execute this, you first, after giving names, you do the summary of the data set and see the summary. And after seeing the summary, go for converting it into continuous to binary. After that, you see the summary. It will be something else. Because I've run that before, I got the same result. For you, when you do it from scratch, you'll not get the same result. Now you have a summary of a data set. You know in age, what is the minimum age, what is the maximum age. In BMI, what is the minimum BMI, which is 20, which is the maximum, it is 35, which is the minimum cholesterol level 113, maximum cholesterol level 284. So these are the summary of a data. We know much about the data with the summary right now. Now simple imputation. Now what we are going to do, just averaging it out. What we do is whichever data which is NA, we'll put an average in these data sets. Just seeing how does this go? How do we change it? Now execution of logical function. You know, is.NA is a logical function in data $BMI. So here we are doing that in BMI data set, which is a missing value, just by running this. True, false. True means it's missing. False means not missing. So again, this is a function which we can use here, which is .NA data BMI is equal to mean of data BMI NA.RM equal to true. You have to say NA.RM equal to true in order to run this function. When it is true, it will run it. This is logical here. So when you have a logical operator, you have to understand why you are putting that in to get what. So when it is true, then only it will happen. It will take out the true values and put those in place of those values, the mean of the BMI. So let's try running it, see the result. Data, I think mean will come. We'll view data and see. Character data. BMI and cholesterol. Okay, we haven't done this for hypertension. We have done it for BMI and cholesterol. So you check in case of BMI, the results of mean are being put in place of NA. All the means are being given here. In cholesterol also, where there was missing value, those missing values are gone. And in case where the missing values are there, NA values, or the average has taken its place. So this is how we average the values out. We have some values which are NA, we average it out and do it. I'll just tell what we do here. We'll take the column which has those NA values. We are using a function called which. We are detecting which is the value which is NA, and we know is.NA is a logical operator. So we are just extracting out which is true in that case, which has NA value. Now those values which are true, it's being replaced by mean of the PMI data, whichever the mean is. So we have done it for two columns here. So we have our results in data sets. Now we are using mice. I'll show you mice there, so that when we do mice, we know what it is and why we are doing it. Multivariate imputation by chained equation. Now we'll go down and see what are the contents, what we have to read a little bit about it. We'll go through this documentation. It's better to read the documentation of each packages while using it and then implementing it. So these are the methods which are present in this package. PMM, sample, cart, mean, norm, so many methods are there. We'll implement 1 and 2 and just see how it goes. You can, after you get the code, after you are doing this, try using others also. If I'm using PMM, predictive mean matching here, you also try doing other things, weight predictive matching. Just try out different things so that you know what are the methods available. So what we are doing here is we are already seeing what we have done in data in this data.enhance. We have done already certain changes. So we cannot take the same data because already the data has changed. So we have to assign this data to some other variable so that we can work with that. Already after doing certain operations, don't use the same data, because then the new operations will take place in that already operated data. So try taking the data sets again if you're using the same file. If you are doing afresh, then it is okay. So mice imputation. So what we are doing is we are taking the data which is input underscore data. I've taken a different name here. Now what we are doing as dot factor. Now we are showing that this is a categorical variable. So after taking this input data, which we are taking as a variable, m equal to 5, we are taking 5 methods here, 5 values which you will be getting. Method equal to c. Now these are methods in a mice package. PMM, sample, so many methods are given there. So I'm taking one of the method here, predictive mean matching. Predictive mean matching I'm taking here, and for first we go through the variables. BMI, hypertension, I think, cholesterol. So BMI is numerical, hypertension is categorical, and cholesterol is also numerical here. Now when we say hypertension here, it is categorical. We have specified it categorical, and also we cannot do any of such things, predictive mean matching on it, because it is categorical. For categorical, we have to find out binary. So here logistic regression is binary. Logistic regression with bootstrap, lasso logistic regression, so many options are there for binary. So we take log reg. This is for categorical data set. So we are taking here log reg. First of all, it is PMM. Second is log reg. Next is PMM. So we are doing such we are applying the methods which are present in this package. And there is last thing is maximum iteration. Maximum iteration, you can give as many numbers you want, But if you give larger number, it will take more time to run and process. But give a medium number, but I've taken smaller one here. I don't want to take just a lot of time to run. So keep it 20, 10, whatever you need, and then run it. When you run, you will get such value: BMI, hypertension, cholesterol. Now let's see the summary. This is the summary. We have now for this data set, we have a mean, we have a third quartile, max quartile, and is one. Now we have the new data set. Now they have this package method has given us 5 numbers, 1, 2, 3, 4 to match with it. Now these are the data sets which are given by these methods. But we know we can actually, this is also trial and error method, but we know we can replace it with average value, if any missing value. So we'll check here what is the mean and which of the value is closest to the average. Average here is mean is 26.56. Which of the value is closest to 26.56 here? I think we'll go through 5. It has larger number, 4 also, it has small number. Third, second, first. The fourth also it is matching with, and I think first is also matching. So we want a clean data. So whichever the data columns we think are mostly matching with the mean, this is a method which we can execute it. There are other methods also. What I'm telling you is one of the method, like which of the column here is more matching to the mean, we'll take that column, and clean data or take any other name, complete my data comma 5. We are taking here it was 5. We can take 4. As 4 number of column is also matching with the data. Now clean data. We'll run this and view clean data. Now we have a data which is replaced properly. It is replaced in a way it's not which is taking into consideration multivariate statistics. It's properly done. So we are replacing those missing value in a proper way, in a proper order, and either use mean, but if mean is also not a viable option for your data check sets, you just try installing packages such as mice or any other package which you think it is viable for your data sets. And for mice, use the imputation, the method which I showed you. There might be other methods also. Try out different method, but this is also one of the method which you can use for filling out the missing value and to get a clean data. And clean data is very much required to work with the data set. We cannot work with the data set which has missing numbers or missing values or any number which is not proper for us to work with, or any value which we have made it so short after eliminating the values that it doesn't give a proper result. The analysis will not give proper result which we want to work with. So these are the viable option to clean a data. First, find out the missing data, then do it accordingly. First method I've shown you before was finding out through logical operation, which is the actually missing value. You find out the missing value. Either you remove the rows or you substitute with zeros. That cannot be a viable option, as I've shown you that deleting rows can lead to shortening of the data, can result in bias, and then it cannot be much productive for our data set. If we use average, this is also an option, but if you go for our package as mice and all, because it uses multivariate statistics, you will have a better command over your data set, and you can work with the data set with better quality data set while doing your analysis. So do implement these packages and use these methods in order to clean your data set. So already going to be 1:45, so I'll just copy these commands so that you people can practice it. Okay, I'll stop sharing and copy it so that in case stop sharing. Okay, you have certain amount of time after lunch, just copy and paste and do your, and don't simply copy and paste, understand what you're doing and do it, okay? This is going to save your time, but understand what you're doing and then. Okay, I've actually copied the whole thing, and please install the packages, do these imputation method, take out different data sets and do it, and do your data analysis on them. So I think I'll take a break. And sir, can you tell me when to come back? What is the time to come back after lunch?
Around 2:15.
2:15. Okay, thank you.
2:15 to 2:20 some. 5 minutes buffer will be there. 30 to 35 minutes.
Okay. Thank you. Please copy and paste and do the analysis. I'll take a break now.
Okay, thank you. I request all the participants to take a lunch break and join by 2:50. Okay, thank you. Thank you, ma'am. Please have a lunch break and.
Thank you.